Final exam for Math 90. We're going to be solving all of the questions that are going to be in your final. Some of these problems will be in your final, some of them might not be in your final, but we're covering the topics that are the most important for your final exam. It's like a review for everything. Now let's do problem number 1. Given that the function f of x is equal to 2x plus 1 over 3, find the inverse function of f. So recall that whenever you want looking for the inverse function, I'm just going to write this first as a y. Y equals to 2x plus 1 over 3. Now, if I want to find my inverse function, what some professors like you to do is they tell you to switch these variables. You're going to replace the x for a y and the y for the x and vice versa. So you're pretty much just switching the places. Like instead of x, you're going to write y, and instead of y, you're going to write x. So that's what we're going to do here. Now, I'm going to read x equal to 2y plus 1 over 3. So now, what we have to do is we have to isolate for y. Isolate for this new y, right? So I'm going to rewrite the equation again. 2y plus 1 over 3. Let's isolate for y, so times 3 top and bottom. And then I have 3x equals to 2y plus 1. Now, subtract 1, so it's going to have 3x minus 1 equal to 2y. Divided by 2, divided by 2. Therefore, y is equals to 3x minus 1 over 2. But this new y is actually your inverse function. So that should be f inverse of x equals to 3x over 2. 3x minus 1 over 2. So that's your inverse function. Now also recall that this was a linear function, right? So a linear function is always 1 to 1. So it's a linear function, so that will be 1 to 1. So therefore it implied that it had an inverse. So for a function to have an inverse, it must be 1 to 1, and this was a linear function, therefore it does have an inverse function. Now let's find the domain and the range of this new function. Now whenever it comes to this part here, first you have to find the domain and the range of f. So let me find the domain and the range of f. The domain of f, because it's a linear function, it's just going to be all the real numbers, and therefore its range is going to be all the real numbers as well. And now how about the domain of the inverse function and the range of the inverse function? Well, the range of f is pretty much, this is the domain of the inverse function, and this is pretty much the range of the inverse function. F to a negative 1 there. So the domain of the inverse function is actually r again, and the range will be r again. So that's the domain and the range for the inverse function. Now let's do the next following problem. Find the difference quotient. F of x is equals to x plus 1 and everything is squared. Now, what is the difference quotient? So some professor will not tell you what the difference quotient is. Some professors, they will give you that information, but just pretend that they do not give you that that statement. We're going to get our formula for the different quotient. Recall that I'm just going to use here red, and I will say that my different quotient will be f of a plus h minus f of a all over h. That's my different quotient. Now let's find that out. Let's find what will the different quotient for this one be. So let's find f of a plus h, and also let's find f of a. Here on the side, I'm first going to try to find the f of a plus h. So f of a plus h will pretty much be a plus h plus 1 being a square. And let's operate this part here. And also remember that this is kind of a binomial being a square. So this will be a plus h square plus twice a plus h plus 1. And now this is a binomial inside as well. So it'll be a squared plus 2aH plus h squared. Now I'm going to FOIL this guy here. I'll get a 2a plus 2h plus 1. So that will be your f of a plus h. Now let's do f of a. F of a is pretty much the same. So f of a will be just a plus 1 squared. Now if I distribute that, or if I FOIL it, or pretty much I'm going to use this binomial square again, that will be a squared plus twice the product, which will be 2a plus 1. So that's f of a. Now they're telling that you have to subtract them, right? So back on here, so then what I'm going to get is I'm going to have a squared plus 2aH plus h squared plus 2a plus 2h plus 1 all over, I haven't done this part here. This is f of a plus h, and then I have to do minus this other f of a, which is a squared plus 2a plus 1 all over h. Well, let's see what are we going to get whenever you distribute this negative number here, this negative sign. So once you distribute the negative sign, you will get the first thing. Well, the first thing is the same, plus 2h plus h squared plus 2a plus 2h plus 1 minus a squared minus 2a minus 1 all over h. Now let's see what things will go away. A squared and a squared goes away. The 2a here with the 2a here, the negative 1 and the positive 1, and then what I'm left with will be 2a(h) plus h squared plus 2h all over h. Now I'm gonna distribute this. What I could do is I could separate them into h, like one here, one here, and one here. Or what I can do is I'm gonna factor the top one, because the top one, they all have an h in common. So I'm gonna pull that h in common. So I'll have a 2a plus h plus 2 all over h. Now h and h goes away. Therefore, the differential quotient is pretty much 2a plus h plus 2. The hardest part of this problem was to find out what the differential quotient is. The differential quotient is this formula, this one here, f of a plus h minus f of a all over h. That's your differential quotient. 3. Find the average rate of change of the function between the given points. So now they're asking you for the average rate of change. What is the formula for that one? That's f of b minus f of a all over b minus a. Now, how are we going to do that? Well, will be your a and this is your b. So pretty much they're telling you to do f of 3 plus h minus f of 3 all over 3 plus h minus 3. That's what we're going to do here. Now look what happened to this. This is nice. This go away and you're pretty much left with f of 3 plus h minus f of 3 all over h. Now the hard part here will be how to find f of 3 plus h. Well, gladly this is just rational function here with 1 over x, so it's pretty much the reciprocal of it, or 1 over whatever the input is. So this will be 1 over 3 plus h minus 1 over 3 all over h. So now we're gonna have like a rational expression that we gotta put into a single fraction. One of the ways to do this, it will be, well, put this h over 1 and now look for the global LCD. So what is the global LCD between 3 plus h, 3 and 1? The global LCD will be 3 parentheses 3 plus h. So what I'm going to do is I'm going to multiply each of them by 3 times 3 plus h. So let's do that here. So 3 times 3 plus h, and also here 3 times 3 plus h. Same technique will go here. Look, 3 times 3 plus h. So what I do in one side, I gotta do to another. But here, what I do in one expression, I have to do to each of them. similar to the equations, right? In the equation, what you do in one side, you gotta do another, but we're working on a fraction. What you do to the top, you gotta do to the bottom. So we're doing this for each of them. Now the reason is because we want to eliminate the fraction. Look what happens here. This and this goes away. This and this goes away. And that's it. So what I'm going to be left with will be a 3 from the top minus parentheses 3 plus h all over, well, this will be 3h times 3 plus h. Now, what I'm going to get from here is this guy here. I'm going to distribute the negative number, right? I'm going to distribute the negative number. So you will get 3 minus h all over 3 times h times 3 plus h. Oh, look what happened. This 3 minus 3 is gone. So you're left with negative h all over 3 times h times 3 plus h. And this h goes away. Therefore, your average rate of function, like the fave, right? F of, right? Like fave, f average. So therefore, f average, right? The average rate of change of that function will be equal to negative 1 over 3 times 3 plus h. That will be your answer. Now, you could also opt to distribute these 3. So, or will be negative 1 over 9. Well, the negative 1 actually goes outside. The negative goes outside, so it will be negative 1 over 9 plus 3h. This will be an okay answer as well. Okay, that's how you find the average rate of change. 4. It says if f of x is equals to 1 plus x squared and g of x is equals to this radical function, find the following functions and their domain. The first option, the first problem is find f of g. So what is f of g? F of g is pretty much f is a composite function, so f of g of x. That's pretty much what they're asking you to find there. So let's see what is g of x. G of x is pretty much a square root of x minus 1, right? And all of these, put in an f there. So what's going on here is that your domain, first of all, your domain for this g of x, right? The domain that you're taking inside. So we should have probably done the domain first. So the domain of this guy here, what is the domain of? Well, remember that x minus 1 has to be greater or equal to 0. So x must be greater or equal to 1, which implies that it's from 1 to infinity, right? So, and also here for f is all the real numbers. So your input of g of x is just x minus 1, keeping in mind that x belongs to 1 to infinity. Okay, so let's keep going here. So what will be my, in the range here, for the range for this guy, the range is going to be from 0 to infinity. And the range for the quadratic is just because it's a parabola shifted up one to the top, which is pretty much going to be from 1 to infinity. Okay, just keep that on mind. So the outcome of this one is f of 1. So it actually doesn't really matter with the domain and the range here, because the domain of the range of g of x is 0 to infinity, so we're fine there. So let's keep doing this problem here. So f of that guy will be, now let's do the math here, 1 plus x squared, which will be this guy, minus 1 squared. And because we know that this guy will be always positive, so we know you can just drop them there. You don't need the absolute value. Plus x minus 1. Therefore, this guy will give you x. Now, so it means that f of g of x is pretty much equals to x. But the hardest part now is how to find the domain and the range. And we were kind of talking about this. So whenever you're doing this, like, let me overview, let's do the same thing. So f of g of x, right? Whenever you're inputting this g of x, the g of x has a domain of what? The g of x has a domain of 1 to infinity. And now after that it comes out to, so we're restricting your domain so far for this. Your domain should start with this. You start with this part here. So after that, whenever you take that out, this g of x comes out to be the range of g of x is from 0 to infinity. So from 0 to infinity, we're fine there because we're trying to look for the range. Wait a minute, we don't need the range no more. So because the outcome will be fine. So you just need the domain for that because they're asking for the domain. So therefore, f of g of x, right? The domain of this guy here, the domain is pretty much 1 to infinity because you're restricting yourself on this guy here. Based on this part here, you're restricting yourself because your domain starts from there. So be careful with this problem. Your domain starts with g of x, and g of x, which is in the square root of x minus 1, can only take from 1 to infinity. So you're restricting your domain already. So that's what your domain should be. So 1 going to infinity will be your domain. Now, part B. Part B of the problem, they're asking you to do find f of g of 2. So let's do that part here. Find f of g of 2. F of g of 2. Well, actually, we did find that from part A. We actually can just use part A. Remember this part here? We can use this. And that pretty much tells you that f of g of e is pretty much going to be equal to the input 2. So we're fine there. So that was problem number part B. So let's do part C. Part C, they're telling you find f of 2. So this is a composite function. We're not gonna look for its function itself. We're just gonna do this part here. F of 2. So let's work the inside here. What is f of 2? Well, f of 2 is actually, well, remembering that f of x is equals to 1 plus x squared, f of 2 will be 1 plus 2 squared, which actually give you 5. So we're going to have f of 5 now. What will be f of 5? F of 5 is 1 plus 5 squared, which 5 squared is 25, plus the 1 there is going to be 26. Therefore, f of 2 is equals to 26. Now let's do part C here. I mean part D. In part D, they're asking you to find f of g. Well, remember that because you're composing this function of f over g, you're pretty much doing f of x over g of x. We also have to look over our domain. Be careful that g of x now, even though each of them has their domain, this guy having all the real numbers, but the one in the bottom part, be careful with that one because the domain, you cannot be 0, cannot take 0. Cannot take 0. Just be careful. We gotta look for that value that will make it 0. So we have to be very careful on that one. Let's keep looking for the function though. Look for the function. F of x is 1 plus x squared over, the other one will be a square root of x minus 1. So what will our domain be? Well, we know that the input here in the top is all the real numbers, so we're fine. And the input, just because we have the g of x, so far is the square root of x minus 1. So it's telling you we're pretty much restricting our domain to be between 1 to 0, right? From the domain of c will be from 1 to 0 to infinity, but because this cannot be 0, we cannot take the 1, because 1, this is 1, this is going to be 1 minus 1 is 0, so we cannot take this, we cannot take x equals to 1. So we're going to exclude that from our domain. Therefore, the domain of f of g of x is pretty much open at 1 to infinity. So that's what your domain is going to be. Pretty much remember, like, you have this part here in the bottom, this rational expression. This has to be greater to 0. Cannot be 0, just greater to 0, because it happens to be in the denominator. Now let's do the next problem. Part E. In part E, they're asking you to find g of f of x. So let's first do g of f of x. What is g of f of x? Well, f of x itself, f of x is 1 plus x squared. And be careful with the domain. What is the domain here? The domain is all real numbers, so we're fine. We're starting with all the real numbers. Let's go for g. So g of this part here will be, well, I'm going to have a bracket there, a radical, and I'm going to put 1 plus x squared, that minus 1. 1 minus 1 is actually give you x squared. The square root of that, and then the square root of x squared is just x. Because we're not restricting anything in our domain, then it appears that your domain is going to be all real numbers. Therefore, g of f of x is actually the domain of this guy is all the real numbers. Why? Because remember here when we're talking about it, that we're starting for the very, very, very inside here, which f of x starts with a domain of all real numbers. And then when you're putting the domain here, it doesn't matter. Actually, it doesn't take anything here. Look, x squared is still being a positive number. So any number that you take, so is fine. So your domain should be all the real numbers. Always start with the inside. The inside is going to be how you're going to start your domain. 5. Find all the rational, irrational, and complex zeros and state their multiplicities. Use the scatter rules of sign, the upper and lower bounds theorem, the quadratic formula, or other factoring techniques to help you whenever possible. So one of the first things that we want to do to find the zeros here is to set p of x equals to 0, right? We have to set p of x equals to 0. So that means that you put an equal sign here. And to solve any higher polynomial degree, like after 2 or 3, 4, 5, anything, etc., you actually need to factor. You got to try to use factoring techniques here. So let's try to factor if they have anything in common. There is an x to the 6, x to the 5th, x to the 4, x cubed, and x squared. We can see that they have an x squared in common. So what are we going to do here? We're going to factor that x squared. So you pull the x squared out, and you're left with x to the 4th plus 6x to the cube plus 17x squared plus 28x plus 20. They don't have any other factor in common, so the only one that we could find is the x squared. But we have to factor this completely. So one of the nicest things on these polynomials, I probably grouping, but grouping is not going to help. Therefore, you're going to have to use the synthetic division, right? So let's use a synthetic division, or this rational, like whenever you're doing, you have to find your possible rational zeros. You could also do that. So it will be very useful to use your possible rational zero, which are p and q, right? P over q here. So what was p over q? Where p is actually 20 and q is actually 1. So you're using all the multiple of 20, which is 1, 2, what else? 1, 2, 4, 5, 10, or 20, plus or minus each of them. So they didn't ask you to list the possible zeros, but it's just going to help you to use your synthetic division. So let's do our synthetic division here. So I do my synthetic division this way. So I put 1, 6, because they're all complete. 4, 3, 2, 1, 0. They are complete. 17, 28, and 20. So this one is kind of like trial and error. Just give you a rough guess. I don't know. I'm going to start with -1. Let's see if -1 works. -1. Then I'll have 1. 1 times -1 is -1. Add 5. 5 times negative 1 is negative 5. 12. Then I have negative 12. It seems like it's not gonna work. Let's see. Then this is gonna be 16, negative 16. No, that doesn't work. So what happens when something doesn't work? I'm gonna erase these parts here. So we're gonna try to use another one. We could have used positive 1, but it seems like because all of my my things here on top, all of the leading coefficients are pretty much positive. So if I just use positive 1, this is gonna get bigger and bigger and bigger. So we have to start by a negative. So how about negative 2? Because we already tried negative 1. So let's try negative 2. Bring the 1 down. 1 times negative 2 is negative 2. Add 4. 4 times negative 2 is going to be negative 8. Now, 17 minus 8. What is that? 17 minus 8. Is that 18? Yes, that's 18. That's 9, right? That's 9. Sorry, 9. Positive 9. 9 times negative 2 becomes negative 18. You add them up is 10. Oh, look, 10 times negative 20. Negative 2 is negative 20. Add them up is 0. So we're looking to have a 0 here in my remainder part. Great. Let's keep factoring this any further if possible. So we used negative 1. It didn't work. There's still little positive coefficient. Let's try negative 4. But negative 4 seems like it's going to go really big there. So how about if I try negative 2 again? It might work. Let's see. 1 times negative 2 is negative 2. Add them up. 2 times negative 2 is negative 4. And 9 and negative 4 is positive 5. 5 times negative 2 is negative 10. Add them up. Oh, 0. See? We have this remainder here again. And this is a trinomial. So the trinomial will be easier to use quadratic formula or factorization techniques. So far, let's see what we have. We have x squared times x minus negative 2 by using the properties, right? The zero properties, the zero theorem, sorry. So it will be x minus 2. And then you have x minus negative 2 again. Well, that was a multiplicity of 2, so I could have just make that a square. It repeats twice, right? So I'm just going to put that as in a square here. So square times x squared plus 2x plus 5 equal to 0. Now, what I'm going to do is, well, I'm going to make this nicer. X squared x plus 2 squared in this trinomial here. I'm going to try to factor this trinomial. But as you can see, all my positive, all the coefficients here are positive, 1, 2, and 5. So we just need to use positive things here. So x times x give you x squared. And 5 is just 1 times 5. They must be positive. This times is x, and 5x add up to 6x. That doesn't work. So it didn't work. When your factorization doesn't work, the other way to find your zeros is by using quadratic formula. So we have to find our zeros now. So let's factor. Let's just find a zero, because they actually ask you just to find a zero. They didn't ask you to put this into factorial form. So let's factor this part here. So if I factor, let's do this into your zeros. X plus 2, x squared, and then you have x squared plus 2x plus 5 equal to 0. Right? This part here is also equal to 0. So what I'm going to get here is x is equal to 0. Right? And then I'm going to have here, what I'm going to have here, well, I'm going to try to use this zero principle. This is x equals to negative 2, right? Multiplicity, I'm going to write the multiplicity because they want you to do the multiplicity here. I'm going to put the multiplicity with just 1, 2. I'm writing it with the multiplicity. So, but this guy here, I can't solve it. So I'm going to use quadratic formula for that guy here. Quadratic formula. So x squared plus 2x plus 5 equals to 0. I have to, the x is equals to negative Let's remember what the quadratic formula was. X equals to negative b plus or minus b squared minus 4ac all over 2a. So it will be negative b, which will be negative 2 plus or minus square root of 2 squared minus 4 times ac, which will be 1 times 5 all over 2a, which will be 2 times 1. Let's do the math here. Negative 2 plus or minus 4 minus 20 over 2. X equals to negative 2 plus or minus the square root of negative 16 over 2. X equals to negative 2 plus or minus, well, square root of 16 is 4, and the negative, because it's inside, is going to be an I over 2. Now I'm going to separate this guy here. This is how I like to separate them. Just going to do this, and then I'm going to do this. Alright, so that will be x equals to negative 2 over 2 plus or minus 4i over 2. X is equals to negative 1 plus or minus 2i. So I have this guy here with multiplicity of 1. So in summary, overall, because let's answer the question. Say find all the rational, so find all the zeros, right? So I'm going to find all the zeros. So the zeros will be, I'm going to write it here, zeros. So my zeros will be 0, right? With actually the 0 has multiplicity of 2, so I have a typo here. So here should be multiplicity of 2. So I got a typo here. That should be multiplicity of 2 because it's being here being x squared, right? So the 0 with multiplicity of 2. And then I have the negative 2 with again multiplicity of 2, right? Or multiplicity 2. And then I also have the negative 1 plus 2i. I only get to take 1. I don't take the pair of conjugates. Negative 1 plus 2i, multiplicity of 1. So this is my answer. This is my zeros and their multiplicities. Now, what if the professor asks you to write this in a factorial form? If they ask you to write this in a factorial form, then we must use this complex zeros. So I'm gonna try to kind of crunch it in here. Oh no, look here, I have more space here. So this will be like a bonus problem here. So write this in factorial form now. Will be, well, the x squared that I have there times x plus 2 squared, and then I have times x minus, this is the hardest part, okay, be careful with this part here, minus the first complex, negative 1 plus 2i, right? And then also x minus the second complex here. So I'm going to leave in space. So it will be negative 1 minus 2i. So it will be x squared times x plus 2 squared. And I'm going to distribute the negative 1 here. So this negative, I'm going to distribute it for each of them. So it will be plus 1 minus 2i. And I will apply the same rule here. I'm going to distribute, so it will be plus 1 plus 2i. So this would have been the answer if they ask you to write it in the factorial form. Most likely a lot of professors are going to ask you to write this in the factorial form, so these two should be your answer. Number 6. Let's do problem number 6. Solve the equations. Find the exact and approximate solution if possible. Correct your answer to 6 decimal places. So I'm giving this exponential equation. So this looks very intimidating, but the fact that it has a 4x and a 4x here, it's bringing something familiar. This looks to be a trinomial. If and only if I could do a substitution. There are two ways to do this problem. You can either do substitution, or you can just straightforward do this factorization. At this level, a lot of students might be familiar with this part here. So, which will be, well, 4 to the 2x is actually 4 to the x times 4 to the x. So I will write it here, 4 to the x times 4 to the x. And this 12 is actually 3 times 4. What is that? 3 times 4? Yeah, that will be 3 times 4, right? So 3 times 4. One positive and one negative. Let's try this out. So this time this is actually 3 times 4 to the x, and this times this is actually negative 4 times 4 to the x. Combining like terms, I'm going to have negative 4 to the x. That doesn't work really nice, right? So we're looking for the positive. So pretty much probably you want to just switch the signs here, and that will help you out there. So that's what I'm going to do here. I'm going to switch the sign, so this will be a negative and this will be a positive. So this being negative and this will be positive, give you positive 4x. Bingo, that's how it works. So therefore, by factoring, you get 4 to the x minus 3 times 4 to the x plus 4 equals to 0. And using the zero property, the zero principle tells you that if these two numbers multiply to 0, therefore 4 to the x minus 3 equals to 0, or 4 to the x plus 4 equals to 0. Now let's add 3 in each side, and you will get 4 to the x equals to 3. Now this turns out into the exponential equation again. To get rid of these, or to bring the x to the bottom, I need to apply natural log in each side. So ln here, and I will have ln here as well. So you get x times ln of 4 equals to ln of 3. All right, you don't really need parentheses there between them, but let's just put them there. Now isolating for x, you will get x equals to ln of 3 over ln of 4. This will be your exact answer. Now how about my approximate answer? For the approximate answer, we need to plug that into the calculator. This into the calculator, let's see what we get. So I use my calculator, and that gave me a 0.7924812504. It's a lot of digits, but remember that it says only correct your answer to 6 decimal places. So let's see, 1 2 3 4 5 6 right here. So this will be approximately 0.792481. That will be my approximate answer. Similarly, that's what we're going to do with the next equation here that we have. So 4 to the x plus 4 equals to 0. Minus 4 in each side. And then I will get 4 to the x equals to negative 4. And I'm going to apply the natural log in each side. So move this to the front. X times ln of 4 equals to ln of negative 4. Oh, wait a minute. ln of negative 4. What's going on there? If I plug that in my calculator, that's going to tell you error. Why? Because the natural log cannot take negative numbers. So this answer is actually not real. We haven't covered that topic yet. So here's no real solution. Not a real answer, right? Not a real solution in this part. So what implies here is that this is going to be our only answer. Okay, so our only answer will be ln of 3 over ln of 4, and this will be my approximate answer. Now another procedure that, be careful here, there's a option 2. What you can do here when it comes to the factoring, in the factoring part, this is what a lot of students try to do here. And let's see, I'm gonna substitute. I'm gonna say this: let 4 to the x be equals to a. So I'll have, then, well, if you square each side here, you're pretty much getting 4 to the 2x is equals to a squared. So I'm going to replace the thing here. I'm going to see this is a squared plus a, right, minus 12 equal to 0. And I'm going to factor this guy here. So it will be a minus 3 times a plus 4 after doing my trinomial trial and error. So, and then you come out to be a minus 3 equals to 0, or a plus 4 equals to 0. Add 3 in each side, you got a equals to 3, or a equals to negative 4. Now, when you're doing this type of substitution, we are so tempted to say, okay, this is my final answer. However, they were not asking you for this a. They were asking you for look for 4 to the x, right? They were actually asking you to look for x. So I'm gonna back substitute now. I'm gonna write 4 to the x equals to 3, and then I'm gonna have here 4 to the x equals to negative 4. So I'm gonna use these two things here. See that? You're gonna use these two equations to solve, and actually are the same equations that you had in here, and actually the other equation that you had in here. So this will be the option 2. Option 2 is very neat, but we're trying to build a lot of techniques that are trying to give us the answer faster, and you have to analyze that this part here looks to be the square of each other, so this will be a trinomial. One of the ways that you might see this question again will be e to the 2x plus 4 plus e to the x minus 12. You could probably have a question like this. See, this is the square of the one in the middle. So you could have the question like that. So be careful whenever you're looking at this problem. If substitution works the best for you whenever you need to factor, then apply the substitution. So let's keep moving on to the next problem. Problem 7 says, solve the equation, give the exact and approximate solution, and correct your answer to the 6 decimal places. And this looks to be a logarithmic equation because it has a log implying to that. Whenever you're working with logarithmic equation, you mostly want to isolate for the log. So let's put some single log here because they have log of base a x plus 5 minus log of this. So let's recall this property. Remember this the property that says log of a minus log of b is pretty much a single log of a over b. So that's what we're going to use here. So I will have x plus 5 over x minus 2. All of these, right, is log of a equals to 1. Now I'm going to change this logarithmic equation to an exponential by using this other property. I always been doing this big A here because I like to use this very particular logarithmic property that says you have base a log of a to the x. That's pretty much x because these two will cancel out. So, but if you do another way that you change your logarithmic to exponential, you're so welcome to do it. So here in the video I'm putting a big A, so these two will go away, and you are left with x plus 5 over x minus 2. And then what is 8 to the power of 1? 8 to the power of 1 is 8. So I need to solve this equation, right? One of the other things that you need to understand is finding the domain. What is the domain of this guy? Remember that x cannot be 2 here, so be careful with that one. And also, like, this whole inside here has to be greater than 0. So far, let's understand that x cannot be 2. If I have to do some checking problem, I will check it. So let's keep solving this. Now I want to get rid of the denominator, so I'm going to have to do times x minus 2 times x minus 2 each side because I want to get rid of that fraction. Eliminate here or simplify. So I have x plus 5 equal to 8. Then I'm going to subtract 5 each side. Actually x plus 5, you couldn't know eliminate here, so why did I say here? So you're actually distributing the a here, so you have 8x minus 16, because this one doesn't eliminate, it's like a over 1. So, well, you still have to do a minus 5 there, so you gotta do the minus 5 there. So x equals to 8x minus 21. Then I'm gonna subtract this 8x in each side, and you have a negative 7x equals to negative 21. Then let's divide by negative 7. Let's divide by negative 7. Therefore, you're gonna get x equals to positive 3. This one it's okay. So far it's okay. But let's see if it makes sense here. Let's when you plug back in here. So plugging it back will be 3 plus 5 minus log base A of 3 minus 2. We're just looking that the inside will be fine because this part cannot be negative. So you're having log of A of 8 minus log of A of 1. So you could have stopped there. You see, check, it works. So this will work. Now if you want to go forward, right, if you want to keep working, well, A of A is actually 1, right, minus log of 1 is 0. Are they the same? 1 minus 0 is 1. Yeah, it works by checking this part here. So therefore your answer here should be x equals to 3. But this was nicer to check because they are easy logarithmics that you can perform. But if there will be a messy logarithmic here that you need to perform, just remember that you're looking at the inside here, the input, this part here cannot be a negative. That's what you're pretty much just checking for. Problem 8, it says a culture contains 10,000 bacteria initially. So initially that's how they start, and after an hour the bacteria is 25,000. Find a function that models the bacteria growth population NT after T hours. Find the double period. Find the number of bacteria after 3 hours. Well, first of all, we need to find out a function that models the bacteria. So let's do part A. So part A, and because this looks to be a population growth, actually here is telling you that it's a growth population, right? So remember the formula, it says that n of t is equal to n naught, meaning the initial, times e to the rt, where r is the rate and t is the time. In this case, our t is going to be based on hours, okay? The t is in hours. And n naught is the initial population. Initial population. And r is our rate. Now, they do give us the hours. They don't give you the hour because the hour is actually the input, like the domain. They give you the initial population. They don't give you the rate, but they give you some information here that tells you that after 1 hour, like when t is equals to 1, that the bacteria, that n of 1 is actually 25,000. So they're pretty much giving you a point, or they're giving a factor. So let's do this. For t equals to 1, they're telling you that n of 1 is equal to n naught, which will be the initial population, right? Let's recall that the initial population, might want to write it with right here. The initial population is 10,000. So n1 is actually 10,000. E to the r, which I don't have it, so I'm going to look for r. N times the time, 1. So n1 is actually, what is n1? N1 is going to be, they gave us, right, 25,000. So that's 25,000. 25,000 equals to 10,000. E to the 1 times r is just r. Now I'm looking for r, so I'm going to divide by 10,000 each side, by 10,000 in each side. And I'm having an answer of, well, the 0 is pretty much gone. 5 goes into here 5 times. 5 goes into here twice. So 5 half is equals to e to the r. This turned out to be an exponential equation. So I'm going to apply ln in each side. Ln here equals to ln in here. Then let's see what we get. We get ln of 5 over 2 equals to r times ln of e. But ln of e is actually 1. And 1 times r is just r. So r is equals to ln of 5 over 2. But I'm trying to look for my equation, right? So I'm going to use an approximation for r. So r is approximated. And I highly recommend to use 6 digits. I would recommend you using 6 digits. So ln, I'm going to use my calculator. I'm going to write ln of 5 over 2, right? 5 half. My calculator says that that's, I'm going to round it to to the 6 decimal place. So it will be 0.9162. Let's say two more, 907, because I want to take 6 digits. So 1 2 3 4 5 6. Then let's just do some rounding here. So that's approximately 0.916291. Okay, so that's gonna be your R. So therefore, what implies here, therefore, the answer for A, right? So the function that models that will be NT equals to N naught, which we know that is 10,000 now, right? 10,000 E to this value of R that we just found, 0.196291 times T. So that will be the function that models this exponential growth. Sometimes professor will tell you 2 digits, 3 digits, 4 digits. I'm just using 6, so because I want my answer to be precise. So let's do part B. Find the doubling period. So part B, doubling period, what does it mean? What does the doubling means here? The doubling means when will be double the initial value, right? Or when will you double the initial value? Well, if it's pretty much asking you when the population will be a final of 10, I mean, if you double 10,000, will be 20,000. Like after how many hours you will have 20,000. That's what they're asking you for. After how many hours you will end up having a 2,000, or after how many hours you will have twice the initial population. That's what they ask you. And naught is actually 10,000, so 10,000 times 2 is 20,000. So let's do this one here. So 20,000. So we're looking for time now instead of R in the previous way. So I'm looking for R, where NT, right, this final here, this NT is 20,000 equal to 10,000 E to the 0.916291 T. Let's solve for that. Divide by 10,000. Divide by 10,000. And let's see what we get here. This is going to be twice, equals to E to the 0.169291 T. I'm going to use a space here. I'm going to apply the natural log in each side. ln for each side, ln here, because I want to bring the T down. So ln of 2, which I'm going to use the calculator soon. Now these whole numbers here, like this really big number comes here, times ln of E. But remember the ln of E is just 1. So 1 times that same thing is the same thing. So you pretty much not need this part. Now over 0.916291, this whole decimal here, I'm going to put this decimal. Now with the help of my calculator, T equals to, let's see what my calculator says. So ln of 2 divided by 0.916291. It tells you that it's approximated 0.75647056. So what will be the doubling period? The doubling period will be about not even an hour. So it's gonna be T equals to 0. Let's just put 6 decimal again. 56471 hours. So that will be your doubling period. So after 0.75, which is about 3/4 of an hour, right? We can see that it's a 3/4 in an hour. 3/4 of an hour is about 45 minutes. Around 45 minutes will be when the bacteria will be 20,000. Now let's do the last part here. Gonna try to sneak this part here. So part C, find the number of bacteria after 3 hours. The number of the bacteria after 3 hours. So find the number. So pretty much finding n of 3. That's what they're asking you. Find the final. What is n of 3? So 10,000 e to the r, which is, well, we're gonna put the big number there again, 6291 of 3. So let's look for n of 3. 10,000, and you can actually put everything in your calculator, but I'm just gonna do one by one, depending if you have an efficient calculator or not. All calculators are efficient. It's just like some of them has the store feature that you can use. So 91629 291, right, times 3. That gives me about 2-ish, 2.748873. Now I'm gonna get this number, right? I'm gonna put e to the power, So let me look for e here on my calculator. So I think I found it. E to the power. E gave me about 15. So n of 3 is equals to 10,000 times, and I have 15. I'm gonna keep all the decimals I have, at least 6 digits. So 6.62501253, and then I'm gonna multiply that times 10,000. 1 2 3 4 5 10,000, and then I'm gonna have n of 3 is equal to 156,250.1253. So that will be the total population. That's how much bacteria will be after 3 hours. After 3 hours is how much bacteria you will have. Okay, after 3 hours. After 3 hours. So mostly they will tell you round your answer to 2 decimal places or 3 decimal places. If they don't tell you, just get to the habit of either using 6 or 4. 4 is okay, 6 is better, but don't use 2. 2 is very it's too short. It's a lot of error if you approximate it to 2 answers and you keep approximating by 2 and approximating by 2. So 6 is fair. 4 is good, right? I mean, I would say 4 is fair and 6 is good, but you can also use 4. So your answer probably is a little bit off than mine, just because of the fact that I use 6 digits instead of 4 digits, decimal places.